Question 18 says a body of mass 1 kg is moving under a central force in an elliptical orbit with semi-major axis 1000 meter and semi-minor axis 100 meter. The orbital angular momentum of the body is 100 kg meter square per second. If time period of motion of the body is n times 100 pi second, then find the value of n. Well, the body is moving in an elliptical orbit, so the concepts of Kepler's laws in fact are applicable here. So that means we need to apply concepts of aerial velocity, angular momentum, the relation between the two. Let's look at the relation again. Say a particle is, well, let me tell you, this motion is similar to motion of a planet in an elliptical orbit with sun at the focus. Okay, so similar concepts will be applicable. The aerial velocity here also will be constant. So if that is the case, suppose this is the source of the point through which the central force is acting, and in case of gravitation this could be taken as the position of sun, and here is the planet, and in time dt it covers a small angle d theta, then we know that the area described at this point dA is simply, if this length is r square d theta by 2, and the aerial velocity dA by d2 happens to be equal to r square omega by 2, and the angular momentum L is mr square omega. So if we put r square omega as 2 times dA by dt, we have L is equal to m 2 times dA by dt, and the aerial velocity dA by dt is simply L by 2m. Now L has been given, m has been given, so we have aerial velocity, the rate at which area is being described, and the total area of the ellipse will be pi AB, the product of pi times product of semi-major axis and semi-minor axis. So pi times AB, that's the area, and the time it will take to complete one period will be then area divided by the aerial velocity. That means pi AB divided by L by 2m. Now let's put the values. Well, pi is pi, and A is 1000, B is 100. So the product is 10 to the power 5, 2, and mass is 1 kg divided by L. Value of L is given as 100 SI units. So this is equal to 2000 pi seconds, right? And that means it is also equal to 100 pi into 20 seconds. So the value of n we are getting is 20. So for question 18, answer is 20. Let's go to question number 19 now. Question 19 says a circular disc is rolling over surface. Velocity of top and bottom points are 8v0 and 2v0 as shown. If velocity of center of disc is nv0, then the value of n is. So basically we have to find the velocity of center of disc, and then we can get the answer to the question. Let's use the concept of instantaneous axis of rotation. So let's say here is the instantaneous center of rotation. The axis is passing through this point and perpendicular to the plane. And let's consider that this distance is x. And if the angular velocity is omega, then we have omega x equal to 2v0 and omega times x plus 2r equal to 8v0. Let's divide the two. We get x plus 2r by x equal to 4, and that means 3x is 2r. or x is 2r by 3, and the value of omega is simply 2v0 by 2r by 3, or simply 3v0 by r. So the velocity of point O is equal to r plus x into omega, and the value of x we already have, so r plus x will be 5r by 3. Omega we have found 3v0 by r, so this is simply 5v0. So the value of n comes out to be 5, and the answer to this question is then 0.5. Okay, let's go to the last question of this test now. Question 20. An ideal liquid of density rho is flowing down in a uniform tube if pressure at point A is PA equal to P0 minus n times rho GH, then the value of n is, and P0 is the atmospheric pressure. Okay, the question is obviously based on application of Bernoulli's equation. We can also say equation of continuity, but the area of cross section is same everywhere, so we can consider that the speed of liquid is same. So let's apply Bernoulli's equation between points A and let's say point B, just outside the pipe. So pressure at point A is PA plus rho GH, and let's say the speed is V, so half rho V square. At point B, pressure is P0, height is 0, and speed is same because the area was same. So this gives us the value of PA equal to P0 minus rho GH. So we can see that if we compare with this equation, the value of n is simply 1. So the answer to this question is 0.1. Well, students, with that we come to the end of this quick solutions. Hope you found the solutions useful. I wish you all the very best. Take care. Bye.